purpose of this is for you to be able to explain how mechanical energy is conserved. Now, mechanical energy, in a definition sense, is the sum of the potential and kinetic energy that an object has. Now, another way of putting this is it's the energy of an object due to its position or its motion. And the reason these two things are often lumped into one thing is because potential energy and kinetic energy can often go right back to one another and transform from one into the other. So it's almost as if it's like one energy. It's because it can so fluidly move from one to the other. Now, its formula is going to be the energy, uh, the the kinetic, the gravitational potential energy plus the elastic energy, potential elastic, and the kinetic energy that an object has. In other words, and this is just the formula written out in words, not in other words, but in words, it's the gravitational potential energy plus the potential energy plus the kinetic. And that all together makes your mechanical energy for an object in a system. Now, let's look at a ball rolling down a hill. All right? A ball rolling down a hill at the start is going to have most of its energy in the form of gravitational potential energy because it's not moving. And the mechanical energy is 100 joules, as is the gravitational potential energy. So as the ball rolls down, some of that gravitational potential energy gets converted into kinetic energy. Now you'll notice that the gravitational potential energy is going down while the kinetic energy is increasing. However, the mechanical energy is remaining constant. So you've got it like you've got gravitational at the start, not a lot of kinetic, and then as it goes down, they go like this. However, the total amount of both of these equals the same amount of mechanical energy. So it starts with 100 joules of mechanical energy up here and ends with 100 joules of mechanical energy. Starts with lots of lots of gravitational and ends with lots of kinetic. Now, here's another example of a scenario where your mechanical energy gets transferred. Let's say you have someone on a spring and they're bouncing up and down, and as they leave the trampoline, they're going to have very minimal gravitational potential energy because they're not far from the ground. They're going to have the most kinetic or high kinetic energy as they leave because they're going as fast as they can. Now, I've made this one a little bit more interesting, hopefully, in that they've got springs on. So let's say they hit the roof of the system, or let's say they're in like a closed space. At this point, the springs are going to compress like this. So he's going to the object in this scenario is going to have lots of potential energy up top, gravitational mainly, and it's going to have some potential elastic energy because the springs that he's wearing are gotten compressed. Now, his kinetic energy would be relatively low. If they were going straight up and down, his potential energy would be 0, but he would have to have had springs on his head. Therefore, he probably must have been rotating. So that's where his kinetic energy is or lies in his rotational energy. And as he comes down, his gravitational potential energy decreases and his elastic energy, after his springs have been compressed and then expanded, he doesn't have any plastic energy, and his kinetic energy is increasing. Now let's look at somebody in a cannonball, or like being launched as a cannonball. Let's pretend they're on a cliff, so they've got some gravitational potential energy and zero kinetic energy. So at the start, the mechanical energy is going to be 100. Now, as he gets launched from the cannonball, he's going to gain mechanical energy, or they're going to gain mechanical energy. So instantaneously, when the boom goes off, he's going to gain some mechanical energy. Therefore, the total amount of mechanical energy will increase. So up here, he's going to have more mechanical energy than he started with. That mechanical energy gets converted into gravitational potential energy. He has further to fall, all right? And as he goes down on his flight, this gravitational potential energy would decrease and get converted into kinetic energy. And therefore, one goes up and one goes down. However, the total amount of mechanical energy is going to remain constant. And hopefully he'll have enough energy in his body to swim back to his boat. So just to recap, the mechanical energy starts at a certain value, but then gets increased because some of the gunpowder makes him have more mechanical energy. And it gets converted from kinetic to gravitational potential energy, and then back from gravitational to kinetic. Now, one thing, this scenario is only talking about up and down, even though the person's really moving in 2 dimensions. It's moving laterally as well. That case, all the mechanical energy laterally actually remains constant. In all of these examples, we are neglecting friction, and that some of this energy that we're talking about, some of this mechanical energy would be lost due to heat. It would get transferred to molecules that these objects interact. So we're oversimplifying it, but all right. I'm sorry about that. Have a great blizzard bag, and let me know if I can help you with anything.